So good morning, all of you, and let's start today's class. In the last class, we have seen Stokes' law and terminal velocity, right? So now some problems we will solve, and then we will go for the next topic. Okay. So this is one problem, small problem. Two identical drops of water are falling through air with a steady speed of v each. Of steady speed v each. If the drops combined to form a single drop, what is the new terminal velocity? What is the new terminal velocity? This is what your problem is. Okay. Now see. Now, first of all, we have two drops and then it is going to be combined. Yes, no? So let M1 be the mass of first drop, and this M2 be the mass of second drop. Yes, no? But these two are identical. So that's why can I write like this? M1 is equal to M2 is equal to M5 because identical drops. That two are identical drops. Okay. Now let capital M be the mass of big drop. Big drop means combined drop. Okay. And therefore capital M is equal to M plus M. Yes. Okay. Which is equal to 2M. Right. And now we know rho is equal to M by V, and therefore M is equal to rho into V. As this is spherical drop, rho into 4 by 3 pi r cube. And therefore this M also similarly, this capital M is equal to what? Rho into capital V. And that's why rho into 4 by 3 pi r, which are capital R. Why? Because this is combination of two small drops. That's why its radius is a little bit big. That is what I have assumed as a capital R. So rho into 4 by 3 pi r cube is equal to 2 into rho into 4 by 3 pi r cube. Now this 4 by 3 pi cancel, this row and this row cancel. And now this r, if I am taking cube root, then cube root of 2 into r, this is what your small r. Yes, no. This is what we got radius of big drop in terms of radius of small drop. Now we know formula. Terminal velocity he is asking. So we have formula of terminal velocity. What is that? Vt is equal to, yes, what is the terminal velocity formula? Follow 2 by 9 into r square, density of Bob minus density of liquid divided by or into G divided by eta. Now this all are constant. This is constant. This all is constant. And therefore I can write Vt is diagonal proportional to r square. And therefore Vt1 divided by Vt2 is equal to what you will get? Yes. What we will get? R1 square divided by this r square, yes, no? R square. Now this suppose r1 square is r1 square only. This r square is this 2 power 1 by 3 r whole square, and that's why this is r1. Okay, so here you write r or r1, choice is yours. Okay, yes. So now here this square, if we will do, what we are getting, r1 square divided by 2 power 2 by 3 into r1 square. This r1 square cancel. Yes. And therefore Pt2 is equal to this. I am transferring here 2 power 2 by 3 into Pt1. Okay. Understood? You can do it yourself. Just we have to transfer the terms. Now do it yourself fast and note down. Now let's move ahead. Next problem. One more problem we will solve. See here. A small steel ball. A small steel ball falls through a syrup at a constant speed of 1 meter per second. If the steel ball is pulled if the steel ball is pulled upwards with a force equal to twice its effective weight. How fast will it move upward? Okay, how fast will it move upwards? This is what the question is. First, try to understand with free body diagram what is going to happen here. Okay, so let us suppose this is a small steel ball. Okay, in case one what we are doing, and in case two what we are doing. So this is I am taking for case one, this is I am taking for case two. Okay, so there is a syrup. So like this is syrup. Now what is the difference in the two cases? See here, this is a case one, suppose, and here it is case two. Okay, this is case one and this is case two. So if I will draw the free body diagram, you just see, you will get clear idea what is going to happen in first case and in second case. So here also I am drawing the free body diagram. Now a small steel ball is falling down through a syrup at a constant speed of 1 meter per second. If the steel ball is pulled upwards, now initially there is nothing externally applied in upward direction. So you have only two forces. That is what? One is opposing force, that is viscous force. It is in upward direction. Let us assume that this is Fv, and downward is its weight, that is mg, and as it is moving with constant velocity phi. Is that clear? And that's why the equation you are getting, that is something like this. This viscous force is equal to what? Mg. Okay, viscous force is equal to mg. Now this is your equation number one. In case two, what we are doing, we are applying the force. This is externally applied force. This is F, which is equal to, this is not Fe, this is F, applied force. It is equal to 2 times its weight. And as it is coming up, okay, as it is coming up, then you will have again viscous force in the opposite direction. Now the ball is moving up, so viscous force is in downward direction, that is Fe. Also one more force will be in downward direction, that is its weight. Is that clear? Yes, no, viscous force, either you are going in upward direction or in downward direction, always it is in opposite direction. So let us suppose this is V1 and this is what? V2. Okay. So here what you will get? Here you will get F minus W is equal to viscous force, we can say Fv. Okay, because here is little bit external force applied. And now we know viscous force is diagonal proportional to velocity. If remaining all things we are keeping constant, then can I write like this? Fv is equal to K into V. Yes. So this is Fv2 and this is Fv1. And therefore Fv1 is equal to K into V1 and Fv2 is equal to K into V2. And therefore equation 1 and 2 becomes how you just see. I am writing here K into V1 is equal to mg. Okay. And the second one, this is F, this is equal to 2 mg. So second equation 2 mg minus mg is equal to Kv2. How you got this 2 mg? You see, this is equation 1 becomes like this. That is, I am writing equation number 3. And then from this 2, equation 2 is F minus W. No. So this F is 2W. 2W means 2 mg minus this W mg. So you are getting what? Mg is equal to Kv2. So call this equation number 4. Now from 3 and 4, what you can say? Yes, from 3 and 4, what you can say? You can conclude that Kv1 is equal to Kv2 and therefore V1 is equal to V2 is equal to 1 meter per second. And that's why when you are applying the force, which is 2 times equal to the mass, then the ball will move up or come up with velocity equal to the velocity with which it is going or it was going down. Okay, so note down fast. So let's move ahead now. And now next one is critical velocity. What is our next topic? That is critical velocity. We have learned terminal velocity. Now critical velocity is what? Okay. So see, the maximum velocity of a fluid the maximum velocity of a fluid in a tube for which the flow remains streamlined. This streamlined flow already you know. Okay. Maximum velocity of a fluid in a tube for which the flow remains streamlined. For example, if suppose this is a pipe and in this fluid is flowing, so maximum velocity of this fluid which is flowing to the pipe up to which this flow is what? Streamlined. And streamlined flow you know already. The velocity of every particle, preceding particle at particular point is same. Yes, that is what is critical velocity. Okay. So very simple definition. How to keep it in mind? The maximum velocity up to which the fluid is streamlined. Okay, right? And now here this critical velocity is directly proportional. So here I am writing critical velocity, that is Vc, is directly proportional to eta, and eta is what, Ray? Coefficient of viscosity. Yes, no? Coefficient of viscosity. Next one, this critical velocity is inversely proportional to diameter of the tube. T is what? Diameter of the tube through which fluid is flowing. Diameter of tube through which fluid is flowing. Next one. So we have seen critical velocity direct proportional to coefficient of viscosity and direct proportional to 1 by d, means inverse proportional to d. D is what? Diameter. Also, critical velocity is inversely proportional to the density of the fluid. Okay, so where rho is what here? Density of fluid. And now if we will combine this all, Pc is equal to, or Pc is directly proportional to what? Eta by rho into d. And if we will add one proportionality constant, this is r, eta by rho into d, where this r is called constant of proportionality. This r is constant of proportionality, and this is also called as Reynolds number, also called as Reynolds number. Okay, what is this Reynolds number? We will see ahead. First, you note down this. Understood? Now, let's see what is Reynolds number. This is what came on the last page, that is Reynolds number. What is this Reynolds number? Okay, it is a dimensionless number, okay, whose value gives an idea whether the flow will be turbulent or not. Okay, so see here I am writing, it is dimensionless dimensionless number which gives idea which gives approximate idea, I am saying, which gives approximate idea whether the flow could be turbulent. Okay, so R is equal to, in on the last page we have seen PC formula. Yes, no, critical velocity formula we have seen. In that, what is the PC formula below? PC is equal to, we have eta or R into eta by rho d, and now R you want, that implies R is equal to rho d Vc divided by rho d Vc divided by eta. Yes. Okay. And it is dimensionless, unitless quantity, unitless as well as dimensionless. It means what? No unit, no dimensions for this Reynolds number. But as I said, that this number will decide whether the flow is turbulent or streamlined or not. So see, when if R is less than 1000 and greater than 0, means if R lies between 0 and 1000, the flow is laminar or steady, that is streamline. Okay, laminar or steady flow, steady flow. Okay, and if this R lies between 1000 and 2000, flow switches from laminar to turbulent. Yes, and for critical velocity, for critical velocity, for critical velocity, R is nearly equal to 2000. Okay, so R is nearly equal to 2000. Okay, so means at 2000 the flow turns from laminar to turbulent. Okay, so that is this R values for particular things. Okay, laminar or steady flow in between 0 to 1000. Between 1000 to 2000 may switch to laminar turbulent, and for critical velocity, this is nearly equal to 2000. Okay, so this is what the use of this Reynolds number. Note down. Now, next concept, that is Poiseuille's formula. So what is this Poiseuille's formula? See here. Volume of the liquid flowing per second through the tube is directly proportional directly proportional to the pressure difference across two ends of the tube that is V is dial proportional to P. Second one, V is dial proportional to fourth power of radius of the tube. Radius of the tube. Next number, inversely proportional to length of the tube. And fourth one, inversely proportional to coefficient of viscosity. Now let's combine all this. So what we are getting is volume per unit second is directly proportional P r power 4 divided by L into eta. Yes, and if I am removing this proportionality symbol and I am adding proportionality constant, that is nothing but pi by 8. So what is the P? Pi by 8 P r power 4 divided by eta L. This is what volume per unit second. Okay, this is what your Poiseuille's formula. So note down fast. Now one small homework problem I am going to give you. Solve it yourself. Very easy, direct formula substitution. Okay, means whatever the values are there, you just substitute in the formula. See here, calculate the rate at which water flows through a capillary tube. Water flows through capillary tube of length 0.5 meter with an internal radius of 1 millimeter. Coefficient of viscosity is 1.3 into 10 to the power minus 3 kilogram per meter second, and the pressure head is 20 centimeter of water. Pressure head is 20 centimeter of water. A little hint I am going to give you. See here, what is given? P is 20 centimeter of water. So that means what, Ray? Rho of water G into H. So H is what here? 20 centimeter. So you can take density of water 1000. G you take 9.8, and this H is what? 20 centimeters. So 20 into 10 to the power minus 2. You will get P value. Okay. Next is what? L is given 0.5 meter. Next eta is given 1.3 into 10 to the power minus 3 kilogram per meter second. And then what is required? R also they have given, I think, yes, 1 millimeter. Here they have given. So R is equal to 1 millimeter. So this is 1 into 10 to the power minus 3 meter. Now you have formula. Can you go ahead? P is equal to pi by 8 P R power 4 divided by eta into L. So substitute all the values and do it yourself. Okay. Answer is 7.4 into 10 to the power minus 8 meter cube per second. Okay. Okay. Solve yourself. We will stop here. Okay.